Assalamualaikum and hi. My name is Muhammad SAJJAD. My supervisor is TS Muhammad Anil binti Hasan. Okay, the title of my project is development of vehicle brake by wire system for mini illegal go-kart. Okay, so this is my poster. So the project background is the conventional brake consists of a basic hydraulic system which sends fluid to each wheel when the brake pedal is applied. So brake by wire technology is the ability to control brakes to electrical components. Brake-by-wire system are one of the by-wire technologies. Okay, so the objective of this final project is to build the functional prototype braking system based on brake-by-wire system method. The second is to investigate the relationship between braking pedal force with rotational motor speed by observation and experimental method. The third objective is to analyze brake system performance in terms of brake pedal relationship and brake response time. Okay, the scope of my project is to develop of brake wire system based on electronic mechanical wash brake system method. Second is the ECU unit, the electronic control unit system is built by Arduino microcontroller. Third is the functionable of the proposed system will be confirmed by the experiment method. Okay, this is my methodology. So the system function is start when the brake pedal is pushed down. So the input data will be sent to the electronic control unit. The ECU will process the input signal. ECU will transmit signal to motor. Motor will rotate based on the applied force. So brake caliper will grip the brake disc. So moving tire will slow down or stop. If no, brake pedal will push down again. If yes, the system is end. Okay, so for the ECU flowchart, the start will be ECU receive input signal from the pedal brake. The ECU will process the input assigned desired position for encoder. ECU will send the data to encoder to rotate at assigned position and speed. The encoder rotates at the assigned position. If no, the ECU will receive input signal from the pedal brake again. If yes, the data will show on display and the end. Okay, so the project design is basically we have a pedal part, ECU part, and the brake system part. Okay, so for the project development, in the braking pedal section, potentiometer is used because it's capable of easily detecting the magnitude of applied force. And the motor driver will be layered on top of the Arduino Uno in the electronic control unit. The purpose of the ECU is to regulate the speed of the encoder and to assign the degree position of the motor encoder and potentiometer. The encoder will be placed on the DC motor in the braking system so that it can regulate both the motor speed and position. The DC motor is coupled to a wedge brake caliper which compress the brake disc and allow the wheel to stop. Okay, so for the project demonstration and the result, I will show at the end of the presentation. Okay, for the conclusion and recommendation, the electronic wedge mechanical system is the approach and theory applied in this project. The system is composed of three components: a pedal, an electronic control unit, and the braking system. In the pedal section, a potentiometer is being used to easily adjust the force applied to the brake pedal. To regulate the motor speed and position, an ECU is constructed using an Arduino microcontroller and a motor driver. So for the recommendation in future work, the ideal PID value must be determined to ensure that brake performance is excellent and implement correctly. The locus approach may be used to get the optimal PID value, which can then be used to conduct the optimal braking performance. Thank you.
For data analysis, on the screen will show four kind of different graph. First is wheel speed versus times. Second is a brake pedal force versus time. The third graph is brake force in terms of torque value versus time. And the final graph is motor pulse width modulation versus time. So the first comparison I will show about the half press and the full press. Okay, as you can see here, I have six kind of data. First, in the 30 Hz input for the wheel speed, and the applied force is full press. Second is a half press on the 30 Hz moving wheel. Third is a 50 Hz full press. Fourth is a 50 Hz half press, and 40 Hz full press, and 40 Hz half press. Okay. So first I will show at the full press and the half press at the 30 Hz first. Okay. As you can see here, the pink color is represent full press, and the blue color is represent half press. Okay, the maximum value apply on the half press is around 2 volts, and the maximum value that apply on the full press brake pedal is 3 volt. So the outcome of the wheel speed will be different. Okay. The full press will decrease the wheel speed until 0 RPM, which means the wheel will be stopped. But the half press only reduce the RPM. The minimum value is until 63, which means the half press only make the wheel to slow down, not to stop the wheel, the rotations of wheel. And the second parameter that I can show on this graph is the gradient, the slope of the two graphs is different. As you can see here, the slope on the full press is steeper than the half press, because as you can see at the brake force graph, the half press use more torque power to stop the wheel than the half press. Because of that, the response of time will be more higher. So the gradient will be steeper. The full press will be steeper than the half press. Okay, for the next data analysis, I will show the graph at the full press on the pedal at the three different input speed on the wheel, on the rotation wheel. Okay, first we have 30 Hz, which is around, the initial value is around 200 RPM. The second is 40 Hz, is on the blue color. The initial speed is around 288 RPM, and the the final is 40 hertz, which is the initial speed value is around 300 3 RPM. Okay, so the force value applied on the brake pedal is same. The three graphs show the maximum value applied on the brake pedal is around 3 voltage. So as you can see here, the lower speed, the lower speed, which is the input is 30 hertz, is reached at the 0 point first. The second speed that reach 0 point is 40 hertz, and the third speed is 50 hertz. Okay. In logical, the slower moving car will stop faster than the faster moving car. So as you can see here, the 30 hertz moving tire will stop only at the initial press on the brake pedal. The tire on the 30 hertz moving wheels is take around 2 3 times to stop the moving wheels. For 40 hertz, at the initial speed, at the initial braking press, it only takes 2-4 time to stop the wheel, and for the 50 hertz moving wheels, take 5 seconds to stop. The gradient, the slope on the graph is same because the torque value on the braking force is same, is giving the same signal. For third data analysis, I will show the difference on the pedal, force brake pedal versus PWM value. Okay, so the data here, the pink color is represent half press on the brake pedal, but the blue color is represent half press on the brake pedal. I will explain about the half press first. Okay, based on the graph, when the brake pedal is being pressed, the value of PWM is increased. At the hold position, the PWM value is decreased to match the assigned degree position on the encoder. After the pedal brake is released, the PWM value is increased so the encoder can reach the assigned position faster. Before it reach the assigned position, the motor will slow down so it can stop at the exact assigned position. Okay. For the full press, based on the graph, for the full press, when the brake pedal is being pressed, the value of PWM is increasing. As you can see here, the distance of the amplitude is more closer than at the initial, than the PWM value at the initial condition. Okay, so at the hold position, the PWM value remain the same to hold the braking position so the wheel can stop moving. After the brake pedal is released, the PWM value is increased so the encoder can reach the assigned position faster. But before it reach the assigned position, the motor will slow down so it can stop at the exact assigned position. and the rest, the value of the PWM will remain the same.